Today I will recreate one of my favorite childhood games in Unity. That game is Storm the House. I thought it would be a fun little project, and I decided to record the process and put together a tutorial from scratch in case someone finds it helpful. I will try to make this as beginner friendly as possible, but I have to find a balance between explaining and video length. So I will show everything I do and explain where I think it is needed. At this point I have created a canvas and some images, and when I created a TMP text I got the pop-up for importing TMP essentials, which is something we want. Then I continued creating text and images and adjusting them until it was time to create the slider effect on the ammo and health bar. This part requires the images to have a source, so I made a simple health bar in paint.net and assigned it to both the bars. Then I set the image type to filled and the method to horizontal. Now we have some functional bars in the game. I fired up paint.net and made a little background for the game. Then I made a new 2D sprite and assigned the breathtaking background to it. It was at this point I realized I forgot to do some canvas stuff, so I changed the free aspect in the game window to a 16:9 aspect ratio, and then I adjusted the breathtaking background accordingly. I set the canvas scale mode to scale with screen size and reference resolution to a 16:9 aspect ratio. I also had to slightly move the UI. This beautiful tower was drawn off camera because art takes a lot of time. We are ready to start doing some magic now, so I made two new game objects, a game manager and a UI manager. After creating a new script for each one, I opened the UI manager in VS Code. We first need to add the TM Pro and Unity Engine.UI namespace, then we need some references to the things we created earlier. Storm the Tower has this fancy looking reload effect, where the ammo bar slides back up while reloading. We are going to recreate this, so we need a bool to check if we should run the effect, and a float value to contain the progress. The reload function is quite simple. It sets the progress of the effect back to 0, updates the ammo text so it says reloading, then sets the reloading bool to true. We need an update loop to run every frame for our reloading slider effect. This should only run while we are reloading, and if the progress is above 1, we are done. So we set reloading to false and inform the game manager that the effect is complete. If we are not done with the effect, we should set the fill amount of the ammo bar to the current reloading progress. This will act like a percentage, because the maximum value of the fill amount is 1, and our max progress is 1 as well. The reloading progress should be increased every frame by a speed value. I chose 0.4 float as that seemed like a nice speed for the effect, and then multiply by the time scale of the game. This is just a simple function we can call with a number to update the amount of coins on the screen. The info text is the one that shows how powerful our wall is and how many gunmen and repairmen we have hired. We will not implement those in this episode. /n adds a new line, because I want the numbers stacked on top of each other. In the update health bar function, we will need to pass in a current and a max value. And in the health text, we will directly show these numbers. For the fill amount, we just divide the current health value by the max, but we need to convert the integers to floats to do so. The update ammo bar function needs to check if we are currently displaying the reloading effect, and if we are, we should stop here and return from the function. Otherwise, the function is almost identical to update health bar. Now let's open the game manager script and create the foundation of the game. We don't need any additional namespaces here, but we do need a reference to the UI manager, as well as a reference to a spawner script we will be making after this one. This is also where the actual reloading logic will happen, as everything we did in the UI manager is just for the visuals. When the game starts, we want to update our UI, so we can call the functions we made in the UI manager to do so. When the left mouse button is clicked, we should shoot, and when the spacebar is pressed, we should reload. The reload function will tell the UI manager to run the reload effect, and we should set the reloading bool in this script to true. The shoot function should not be run if we are reloading, and if we are out of ammo, we should trigger an automatic reload, then return from the function. If we were allowed to proceed with the function, we should remove 1 ammo per click and shoot a ray straight forward from where we clicked on the screen. If we hit something, we should check if the hit object is a unit by checking if it has a unit script attached, and if so, the unit should take some damage. At the end of the shoot function, we call the UI manager update ammo bar function to display the new ammo value. This function is already being called by the UI manager when the reload effect is done, and all it does is complete the reload logic by setting ammo to max, turning off reloading and updating the ammo UI to the new value. This function can be called to complete the wave by increasing the current wave number and telling our future spawner script to stop creating units. In episode 2 we will implement the shop logic and UI, but for now we leave a little comment. The take damage function will decrease our health by the amount that was sent into the function, and if our health is now below or equal to 0, then we have lost and should stop the spawner. Set health to a low amount and open the shop. Finally, we just need a little function that can give us more coins. At this point, you will have a few errors when you return to Unity. This is okay, it's just because we have made references to scripts we haven't made yet. So let's change that by creating the last 2 scripts needed for this episode. The spawner will only create swordmen for this video, but I'll make a more advanced spawner in probably the next episode that can handle different unit types plus wave logic. Prefab is a reference to the swordman we will make when the scripts are done. Units will spawn between these 2 transforms, and the units will be given a target that they will run to and attack. A swordman will be created every 5 seconds, and we should keep track of whether we are spawning or not, how many to spawn, and how many we have spawned. The update loop should only run if we are spawning, and if the current frequency is above 0, we should decrease it over time. This is equal to seconds. If the frequency is below or equal to 0, we should spawn a new unit and reset the current frequency. When the start spawning function is called, we should reset the amount of units we have spawned, and we should set the spawning bool to true. This will generate a random vertical position between our two spawn transforms. In the spawn function, we create a new game object by instantiating based on the prefab unit. In the position parameter, we simply run the getSpawnPos function, and as rotation, I set quaternion.identity. Then I get the unit component from the new game object, and as a failsafe, I check if I actually got it before I run the initialize function in the unit script, which needs a reference to the spawner script and the game manager. If the amount of units we have spawned exceeds the amount of units to spawn, then we should stop spawning. I got an error because unity.mathematics got imported automatically, so I'll remove it because I don't need it. Quaternion should be with a big Q, and that's it for the spawner. The unit script will be nice and short, so we're closing into something playable. These values are public because I intend on using this same unit script for every single unit. So I want to be able to play around with these values from the inspector. The target position tracked by the unit is the position from which the unit will launch its attacks. So we only need the X position from the target in the spawner script, as the spawner sets the unit's vertical position when it is created. When we take damage, we reduce our health, and if it becomes less or equal to 0, the unit died, so we should be rewarded with coins before the unit is destroyed. In the unit's update loop, we want to track the distance between our current position and that of the target. If this distance is above our attack distance, then we should be moving towards the target by finding the direction, setting a move amount per frame, and then moving the transform by direction multiplied by the move amount. If the unit is within the allowed attacking distance and we are not attacking, then we should set the animator to loop the attack animation. This function will be called from the attack animation itself. I will show you when we create the unit prefab. Now, remember to hit Ctrl+S on each of your scripts to actually save them. I got a little error when I returned to Unity because my start function in the spawner script has the same name as the built-in start function that runs at the start of the game. This is an easy fix though, we just change the big S to a little s in the spawner script and where it's called in the game manager. Let's create some game objects and fill some inspector fields. This is the transform that spawned units will attack. units will spawn randomly between these two transforms. Now we just need to drag and drop the objects into our scripts. We skip the prefab because we haven't made it yet. The final thing we need before we can hit play is some swordmen. So I drew a little stickman in paint.net and I chopped off his limbs because I will be using Unity's animation system. I selected the .png and the texture type should be sprite and the sprite mode should be set to multiple. Then we can open the sprite editor and automatically slice out the parts of the stickman. We will use the pivot on each sprite as the rotation origin for each limb, so they must be placed right. You can always just change this around later though. Let's just move these two out of the camera and move the camera further back to prevent any clipping issues later. This part is going to take some trial and error. I've basically just created a bunch of sprites and assigned the body parts to them and placed them all in a logical structure, like placing the foot as a child of the lower leg, so that when the lower leg moves, the foot follows. Again, this part is trial and error, but the end goal is a character you can play around with like a toy. For the animation part, you need access to the animation and animator window, which you can find here. We only need a run and attack animation, but for these to look good, we should try to create a perfect loop. One way to ensure this is to simply copy the first pose and paste it as the last pose. It's up to you how much time you want to spend on this, as this is just for the aesthetics. The attack animation should also be a perfect loop, and let's give him a sword so he can become a true swordsman. We also need an event keyframe for the attack animation, and it should trigger the deal damage function on the unit script. With the animations done, we can make an animator controller and an animator override controller, because I intend on reusing the foundational stuff on multiple units. We drag the animator controller into the overrider, and with the animator controller selected, we can open the animator window and create two new states and assign the animations to them. We also need an animator bool that we are already calling from the unit script, and we will use this condition for entering the attack state. There should also be no exit time from the run animation. With this setup, we can easily create new override controllers and assign other animations to them, and then drop the override into the unit's animator component. I set the collider slightly bigger, otherwise it would be difficult to land hits on these thin soldiers. With that done, we can prefab him and assign him in the spawner. But before we hit play, I need to assign some values in the game manager that I forgot earlier. Just need to set max health and ammo above 0, and set the current of each to the max when the game begins. We also need to call the start wave function. We hit play, and with that we conclude the first episode. We have created the fundamentals, and we have something playable. In the next episode, we will be looking at implementing the shop and more advanced wave logic with more unit types. Thank you so much for watching. If you enjoyed this little tutorial, then I would appreciate a like on the video. If you like code and game development and my content seems interesting, then I would truly appreciate new subs.